Hi, my name is Luke, you can call me Lucky, and today I'm a little sick. So I might be coughing a little bit throughout this video, but I'm not going to let that stop me from education, because education is important. I wanted to start this video off with a small tangent about my friends. You see, since I moved to Japan, I haven't seen any of my friends in a really long time. For some, it's been years, literally years. But my best friends still find the time to write me letters. And so you can kind of understand how excited I was when I heard that some of my friends would be coming to visit me in Fukuoka. And of course, the first thing that comes out of their mouth is, hey, can you be our tour guide? Or, can I stay at your place? Or, you're gonna show us the secret side of Japan, right? Whatever that is. And, bro, you can drop work for like a month and hang out with us. And, well, let's just say the answer to most of those is no. The answer is no. But regardless, Fukuoka is an amazing place to tour and visit, and one of the things that I can do is recommend some places to visit while they're here on vacation. And Fukuoka has so much to see. Fukuoka is the 6th largest city in all of Japan. It is the largest metropolitan area in the island of Kyushu. It has a subway system, an international airport, and generally a wealth of culture and knowledge available to anyone to enjoy and see Japanese culture for the first or 50th time. And I absolutely am going to give you some banger recommendations, but in order to do that, I am going to need to enlist the aid of my special tool, GIS. Today we're going to be using QGIS, but GIS, the process, generally is how I'm going to give an effective and efficient recommendation of all the places that I'm going to recommend. And in this video, I also want to do a bit of teaching about GIS mechanically. So specifically what I want to talk about is data entry and data symbology. And we're going to get to what that is in just a moment. For the people interested in touring Fukuoka, I have a bit of a different goal, and that is to essentially speedrun all of the places that I'm about to recommend, and in the process teach you a little bit about their background and culture and things that you can do there. So let's do that. But before we can do that, we need to step back to the basics. And the basics is this: the individual data point. You see, usually when I make these GIS videos, the first thing I do is collect spatial data. You know, that's all types of data. It's elevation data, boundary data, network data, and so on. But here is where we find our first problem. You see, no one in the greater GIS community has ever thought to themselves, you know what I should do with my free will and spare time is I should look for a random city in Japan and make an arbitrary list of a dozen or so random tourist spots and then geolocate that data and then make that data publicly available to anyone. Because why would anyone do that? That's kind of absurd. And so at this point, we really have only one option, and that is to make the data ourselves. I say ourselves, but I'm the one who's doing it. Make the data myself. And so that's where data entry comes in. But before we can get to data entry, we need at least a cursory understanding of what projections are. In layman's terms, projections are the shape of your map. And it's important to know what projections are, because when we're entering data, we want to make sure that the projection of your project and the projection of your data are consistent, because if they're not, things are going to get out of line and out of order really quickly. Alright, so we can start by checking our projections simply by going to Project, Properties, and then navigating over to the CRS. The CRS stands for the Coordinate Reference System. So by default, this project is being projected with this projection here, WGS84. Now, there are different projections that you can be using, but in this case, WGS is going to work just fine. Things don't need to be centimeter accurate, things are just as they are. But what's important is that we remember what projection we're using. So we're going to hit OK, and we're going to come back to our data. Now, there are two ways to input data into, there's more than two ways, obviously, but primarily there are two ways. So, for example, the first way is we create a layer. We're going to go here, create a new shapefile, and we're going to call it demo_points. Demo points. We're going to give it a geometry type. I'm going to keep it simple. I'm going to keep it as a point. Here we're going to make sure that our projection is the same as the one that the project said it was. So in this case, WGS84, keep it consistent. I'm not going to worry about the fields because it doesn't matter. We're going to hit OK, and now we have a new layer called demo points. We can then go to toggle editing, and then we can go to this add point features tool, and it gives us this little crosshair, and then we can kind of zoom in and manually look for things to add data points to. So things that are easily identifiable. So like, for example, this is Ohori Park. I can tell from a distance. So I'm going to go here, click right up on the center. I'm going to give it an ID of 1. I'm going to hit OK, and then boom, we have a small little data point added in. Perfect, just like that. I'm going to look for another identifiable feature, maybe this airport. I'll click on like the main structure, hit number 2, ID 2, and that's it. And that's basically the easiest way to import data. But here's the thing. This requires a lot of manual labor, a lot of guessing work, and it can be pretty inaccurate at times. So we need to do something else that's a little bit more accurate. And the way that we're going to do that is with a CVS file. In other words, an Excel sheet. And so I'm going to show you what that looks like. Basically, I'm going to open up an Excel sheet, and I'm going to create some labels, and I'm going to populate those labels with data, and this is a single data point. For this project, I'm going to keep it very simple. Each data point is going to have an ID, a name, a latitude, a longitude, an opening time, and a closing time. And the opening and closing times are going to be in a 24-hour format, mainly because it's a little easier to represent once we get into data symbology, but we'll get into that in just a bit. Basically, 6 points here, and it just looks like that. It's very simple. Now, you got some questions. How did I get the latitude? How did I get the longitude? Well, that part is also quite easy. I'll show you. All right, so we're here in Google Maps, and really all this boils down to is I'm going to find a location that I have a point of interest in. So for example, let's go back to Ohori Park. Actually, is Ohori Park already the example data? No, it's not. So we're going to go to Ohori Park. I'm going to right click. I'm going to grab the latitude, longitude. I'm going to make a new data point. ID number 2. I'm going to give it a name, Ohori Park. I'm going to copy paste the latitude, longitude. Make sure your latitude and longitude are lined up correctly. If they are reversed, you're going to get a transverse of your location data, and it's not going to be correct. I'll show you what that looks like once we get into our data. Opening, closing time. Ohori Park is open 24 hours, so I'm just going to put 1 and then 24 for our opening and closing time. And basically that is how we import data. And let's save this file real quick. I'll show you how we get from an Excel sheet into QGIS. So here we're going to go to layer. We're not going to create a layer because the layer has already been created. The layer is the CVS file. Instead, what we're going to do is we're going to add layer. Add, implying that the layer already exists. And it doesn't have an option here for Excel sheet. Instead, what it's called is the limited text layer. Delimited just means that there's a marker that is separating all of the data values. So we're going to go to file name. We're going to navigate to locations demo. We are going to here it says that it's delimited by tabs, and that is probably correct. It's not correct. It's a CVS. I think I've been saying CVS this whole time. It's CSV, comma separated values. Is that right? Is that what the... All right, for the remainder of this video, I'm just gonna call it an Excel sheet. So CSV, we're going to, X field is going to be our latitude, Y field is going to be our longitude, and then again, we need to make sure that our projection is lined up correctly. Projection's fine, data is showing up down here, everything looks to be a go, so we click add, close, and now when we look at our data, matter of fact, we can just zoom to layer, we can see that our data shows up exactly where we want it to. And so this is a much more precise way to input data from an Excel sheet into QGIS. Now, I'm going to do two things the wrong way to show you what happens when you do them the wrong way. So let's start by adding a layer. Actually, you know in the cooking shows when the person has already like baked the cake, and so you don't have to wait for them to bake the cake on the cooking show? I've done that with the data. I finished the data. So location's finished, that's our data. I'm going to input it. Oops. Oh, hold on. Oh, buddy. All right. So first we're gonna do latitude, longitude. That's okay. But we're going to use a different projection than the one that the project is using. So here we're going to use an azimuthal equidistant, and when we input the data, we'll see that we don't see the data. Where's the data? Well, it's over here. Wherever this is, this appears to be not in Japan, probably not on Earth. I don't think this data exists at all anywhere. It's just like somewhere in space or the ocean. This is what happens when your projection is not the same for the data and the project. Okay, now we're going to remove that, and we're going to do this one more time incorrectly. We're going to go to layer. We are going to add the delimited text layer. Again, navigate to our data. And this time, instead of doing latitude, longitude, we're going to do longitude, latitude. And then we're going to fix the projection is going to be correct. Now, when we add the data, we're going to zoom to the layer, and we're going to see the data has been transversed. It's been rotated 90 degrees, and once again, we are on no known plane of existence. Not helpful to us, not useful. The lesson from this is make sure that your latitude, longitude are lined up correctly. Make sure that your projection is correct. I'm going to remove that layer. And we're going to do this one last time. You don't need to see this bit. I'm just going to do it in post. Okay, so these are our data points. Our data points are now all lined up in here. Now, they are a little hard to see, aren't they? They're just like a little hidden. I mean, it's a really busy image we're looking at. So how do we fix that? Well, what we do is we double click on our layer, and that's going to bring us straight to symbology. Symbology is the symbol that represents your data, and there are a few easier things to look at. So like, for example, if I wanted to make it really big, really bright, really orange, I'm going to hit this honeycomb, and then I'm going to hit apply, and then, oh, look at that, all of our data is very clear now. We can see exactly where all of our data is. Now, that's fun and all, but there's actually something more that we can do with symbology. We can use our symbology to represent information that the data points are holding. So recall earlier how each of these data points have an opening and closing time. Well, I want to know what time each of these locations close. So what we're going to do is we're going to go up to this top here, field of symbology. Here it says single symbol. We don't need a single symbol. We need multiple symbols to show us multiple different closing times. So what we're going to do is when did you graduated? You graduated, categorized. Either one could work. This isn't a strict. Yeah, this isn't a strict science bit here, but we'll use categorize for is keep it simple. The value that we're going to represent is the closing time. The symbol is not going to be the honeycomb. Symbol is going to be something much more simple. Blue dot, sure. It's going to be a dot generally. And then we are going to change the colors. So color ramp goes from white to deep, deep red. And lastly, we're going to classify. Classify basically just puts all of them in groups. And so here, our first closing time is going to be at 5 p.m. and then the latest is going to be at midnight. Now, this is a little confusing because white looks like that closing time is very lenient. When I look at a map and the gradient goes from white to red, red makes me think very urgent. But in this case, red is actually better for us. It's more lenient in time. So what I'm going to do is I'm just going to go to the color ramp and I'm just going to customize it. And so I'm just going to reverse it, basically. So make this a deep red. Make this white. Perfect. And then I'm just going to go ahead and delete all of these points in between. And that reverses the color ramp. Okay, now when I apply and we come back out to the data, we can see that our data points now represent the closing time of each of these locations. And using that information, I can now see that the best course of action would be to start my journey in the southeast. If I start my journey over here, these areas that close the earliest, I can ensure I get a chance to see them. Then I'm going to make my way to the northwest, where these areas, which have much lighter colors, indicate that I can arrive there much later. And that's it. That's the science, that's the analysis. Basically, it's just showing me where I should start and stop my journey. I'm going to start down here. This is Dazaifu Tenmangu and Kyushu National Museum. And then I'm going to end my journey all the way in the northwest at Fukuoka Tower with a night view overlooking the city and the sea, and it's going to be beautiful and romantic and a wonderful story and journey for everyone. I hope that is the case. Also, I just remembered, if you can't remember something about a data point, it's really simple. You just go up to this tool up here, it goes with the eye, it's eye for information, and then you just click on it and it'll put up the values. So like I can remember that, oh yeah, Dazaifu Tenmangu Shrine, Kyushu National Museum, Fukuoka Tower. I don't need to guess and remember. You can just click. Make your life easier. All right, that is basically the tutorial. I've showed you how to input data. Let's take a step back here. Even before that, I taught you very quick, very superficially what projections are. I taught you how to input data in 2 different ways. I taught you how to symbolize your data on your map, and I showed you the plan for our Fukuoka speedrun. Now, in the either latter half of this video or in a separate video entirely, I will be speedrunning throughout Fukuoka in one day, presumably one day. I highly doubt it's going to take longer than one day to see all of these places. Fukuoka is a quite compact city. That's not quite true. It's quite big, but it's very accessible. And I believe seeing everything in one day is more than doable, time-wise. Energy-wise, yeah, I might be a little tired, but I'm gonna do it. I'm gonna do it just to prove a point, because I like proving points. And also, probably I'm gonna do it when I'm feeling a little better. Just recover my health up a little bit. And at this point, I have nothing more of substance to say. So, thank you for watching. I hope you learned something new today. I'll see you in the next video. Until then, take care.